Folks, I wanted to make a quick video on a couple of the problems on page 8 just because I have gotten quite a few questions on these with using both the shortcut and the regular method of distributing with those complex roots. So remember, when you turn a root into a factor, it's always x minus the root. But when you're dealing with these complex roots, it's difficult to remember that it's always x minus the real part. So if these roots were just 1 and 1, it would be x minus 1 and x minus 1, a repeated root. But because the complex part is different, negative I and positive I, that's where the sign change happens. So notice that when I go to write these two complex roots as factors, they both have x minus 1, and then one gets a minus I and one gets a plus I. So that's the first challenging part about these problems, is just making sure you know how to write those roots as factors. So same with on this one, if 1 plus 2i is a root, 1 minus 2i is a root, and when we turn those into factors, it's x minus 1 plus 2i, and x minus 1, again, minus 2i. So sometimes what I recommend doing is just cover up that imaginary part and say, how would I turn 1 into a factor? It would be x minus 1. So don't get hung up with the conjugate part of those complex roots, and make sure that you write those factors correctly. Now, the other questions that I've been getting on these problems is, how do we do the shortcut? Or how do we do it the long way? Or does this answer look correct for the foiling? So folks, I'm going to show you that shortcut one more time. So if I had x minus 2 and x plus 2, kind of our difference of squares factor setup, we can square the first term, we can square the next term, and then a minus sign goes in the middle. Notice that I didn't show the full foiling here because our outside-inside products always cancel each other out when I have same stuff but opposite sign in between. So folks, when we look at number 2, these are my factors for those complex parts. Notice that the x minus 1 and the x minus 1 kind of correspond to our x up here, where I have the same stuff for the first term slot, and then we have negative I and positive I. So same green stuff, same yellow stuff, opposite sign in between those. So instead of doing superfoiling and doing those 3 terms to those 3 terms, I can group the x minus 1s as one item and square them just like I would square the x squared. So that's where I get x minus 1 squared. Then if I FOIL that to the I, we'll get positive x minus 1i and negative x minus 1i. And then negative I times positive I is negative I squared. And a lot of times students will forget that negative in front of the I squared, which is important because negative 1 turns into a positive 1. So notice that with this setup, my outside-inside products cancel. I then FOIL the x minus 1, which gives me this, and then adding the 1 from the negative I squared gives me that for my expression. So folks, that is the shortcut, but if you don't like it, I know it is kind of confusing. Honestly, when I encounter these problems out in the wild, I usually just FOIL it by hand because I don't always trust myself with these. So you can always super FOIL it. Just make sure all your I stuff cancels, because again, when we have our function in standard form, we shouldn't have any imaginary stuff left. It should just be regular old integers. And also be aware of that negative I squared. So folks, what I recommend doing is maybe pausing this video and then try number 3 on your own, doing the setup and doing it either with the shortcut or out by hand. So folks, hopefully you had a chance to try number 3. So this is what the work looks like using the shortcut. So x minus 1 squared. My outside and inside products end up canceling each other. Negative 2i x minus 1, positive 2i x minus 1. And then when I multiply these 2 terms together, we get negative 4i squared. Sometimes students forget the negative. Sometimes they forget to multiply those coefficients together. Sometimes they just write I instead of I squared. So lots of things to remember with that last multiplication. I squared is the same as negative 1. So negative 4 times negative 1 is a positive 4. Plus the 1 from foiling this stuff leaves me with x squared minus 2x plus 5. And then distributing that x cubed to everybody gives us that final function in standard form. form. So making sure you have f of x equals or y equals to denote this as an equation. And folks, on my math lab, it should give you specific instructions on whether it wants y equals or f of x equals. So as always with my math lab, make sure you are reading those instructions carefully.